Kia ora koutou, ko Douglas Walker, toko ingoa. Apologies for the slight delay there, technical hitch at our end. Once again, we've got the wonderful Sujata with us, who's going to lead us through some level 2 organic compounds for your level 2 chemistry external. We'll have a short break after that, and then we'll launch into the final of the externals with Sujata. While we're going, if you'd like to type any questions into chat, it was great to have some of those for the session last night. And I'll either interrupt Sujata and ask the question, or I'll collate them towards the end. So yeah, thanks very much for hanging around there for a moment, and I'll hand over to Sujata now. Thank you, Sujata.
Thank you, Doug. Thank you, students, for waiting. Sorry for the delay. I won't wait much. I'll go straight into your organic chemistry. Like yesterday, I've made some PowerPoints, and I'll share my screen with you. Yeah, this topic is a simple one, but again, it requires a lot of practice. You need to write and practice it, and that is the key to success in this one. There is no this topic does not have any surprises in for you. It is a straightforward one, but what it requires you to is keep on practicing. So in today's organic chemistry, normally your first questions or the first two questions would be on the naming your, they might give you the structural formula and you have to name them, or they will give you the molecular formula and you have to draw the structural formula. They are simple and straightforward. So let us go straight into it. The other things to look at, what I will also along with, so we would be looking at the name and structural formula, the Kris and the trans isomers, the questions to physical properties, polymers, and this reactions. And for this, what I would suggest is, so if you have prepared your own reaction charts for all the reactions, great. If not, if you run out of time, please go to the No Brain Too Small. They have summarized the entire reactions for you with all the links, so that, and if you can print it out, or if you can, I would suggest draw it on a piece of paper so that you can remember what each reactions are. And the last part which I would be looking at is also identifying unknowns. That is, you would be given a question which talks about there are 3 or 4 different types of liquids, and they might be an alkane, they might be an alcohol, they might be a carboxylic acid. How do you identify which is which? Now, the only thing you have to remember while answering this question is you follow your scientific method. That is, just as you would have done your reactions, you would have done in year 11. When you are doing an experiment, we identify, we follow the steps. Okay, this is the first step I did. Then I go to this, then I go to this. And that is very much needed if you have to get an excellence in this particular question. So this question, along with following, how would you scientifically identify which are these products, and therefore scientific process is a must in this question. Now, these are the functional groups you have, and I've color coded them to the C for the black one is for carbon, the plain one for hydrogen, oxygen is red, chlorine is green, and nitrogen is N. Now, why I have color coded? Because on the basis of that, you have the alkane, alkenes, alkynes. Now, remember, alkanes do not have double bonds. They are straight with carbon and hydrogen. Alkenes have double bond coming in between, and alkynes are triple bond where the hydrogen is not present to complete the 4 bonds of carbon. Haloalkenes means where you have a halogen, that is the group 17 one, whether you have a fluorine, chlorine, bromine, iodine attached to the alkene. Alcohols, you have an OH group attached. Amines, you have an NH2 attached to it. and carboxylic acid is COOH attached to your main group, that is your hydrocarbon group, where hydrocarbon is CH. So why do we call it hydrocarbon, and why the topic organic? Mainly because majority of the compounds found in nature is a carbon and hydrogen compound, and hence the term hydrocarbons. Now, alkenes, so you see these are the hydrogens, the black ones are the carbon, and you see the hydrogen is attached to it. So while naming, what you do is identify the longest carbon chain. You would also know that if there's only one carbon, it is meth, 2 it is eth, 3 prop, 4 but. These are the words you have to go up till 8. Normally up till 8 is asked. 8 carbons means it starts with oct. So if it is 8 carbon alkane compound, it can be an octane. If it is a 7 carbon alkane, it will be a heptane. So this is how it goes. So you count, and now when there are additional compounds attached to it, you will have to number the carbons in such a way that wherever the additional functional group is attached has the lowest number. So, and the prefix goes to the long chain. Remembering alkanes are non-polar. Last class, yesterday's revision class, we learned about what a polarity means. Polarity is its electronegativity, and for an alkane, it has high boiling point and melting point because it is difficult to break these bonds. Alkenes, you can see here, there is a double bond attached. So that means this carbon is not having its complete valence shell attached to it. And again, as the chain increases, the boiling point and melting point increases. Also, you have, it's also non-polar and it is insoluble. Haloalkane, so you see, I've put a chain where the chlorine is attached. Now, in the haloalkanes, you have 3 types. That is a primary, and primary means it is only attached to one other carbon. So if this is a carbon, there's another one more carbon here. But if you had a chlorine at this point, you would have 2 carbons attached to it. That is, this would be a carbon, this would be a carbon, and this would be a carbon. So you have a 2 bonded to a carbon, that is 2 other carbons are bonded to where the carbon is. So it can be, that is, if you have a Cl here, then you have a carbon here and a carbon here, and that means you have 2 carbons bonded to where the Cl is. And if it is 3, you will have another carbon bond. Instead of a hydrogen, you would have here another C attached, and that would be a tertiary haloalkane. Now remembering halogens can, I've only put chlorine here, it can be a fluorine, it can be a bromine, it can be an iodine. Alcohols, so it has an OH group attached to it. So, and that is how it is. Again, this also has primary, secondary, and tertiary, the same way as we have talked about in terms of the haloalkanes. Amines, you will see there is a nitrogen here and 2 hydrogen attached to it. Okay, and attached to the carbon. Again, while naming it, you have to ensure when a functional group is attached, you have to start numbering your carbons from the lowest, so that the functional group has the least number of carbon. That is how it goes. So the least number. Here I put the prefixes to the carbon. If there is only one carbon, it is meth, 2 it is eth, 3 prop. So all of this I've written for you. And later on, once the session is over, I will share this PowerPoint so that you all can go back and revise through it. Now, this is typically the questions that come. They would have given you, this is the molecule, this could be the name for it, or what we call nomenclature means naming. So they have given you the name. You have to draw the structural one. Here, they have given you again the name. You have to write how you have to write its structural formula. Now in this one, so here you see there are, in this, how would I name this? There is 1, 2, 3, 4. So it is 4 carbons, therefore it is bute. And on the, when I name here, you would see the carbon is the chloride one, is on the second carbon. So when I name this, I would say 2-chlorobutane. So that means the chlorine is attached to the second carbon, and there are totally 4 carbons attached. So it is 2-chlorobutane. So that is how I would name it. And this is an example of that. Now this is one of this questions on cis and trans is always there in your exam, and this normally comes as an excellence question. It can be either your second question or your third question, it depends, but definitely it does come. And cis and trans is only possible, that is how you write it, you have to ensure. So that is what the cis and trans isomers you will be given. You have to, if they are given you have to redraw them. And what you have to ensure is that there is a carbon-carbon double bond. So there are certain things which you need to always specify in this particular answer. That is, there should be the cis and trans isomer is only possible if there is one thing, it is a carbon-carbon double bond, and on both the carbon atoms, there should be 2 different functional groups attached. It has to be, once again, I stress the importance here. It is the cis and the trans isomerism is only possible if there is a carbon-carbon double bond, and both this double bond have 2 different groups attached to it. So, but you have to remember, and you have to state that the carbon-carbon double bond cannot shift its position. Only the 2 different groups can shift its position. The requirement, you have to link the requirement to 2 different groups of each of the carbon on the double bond, and you have to specify what your molecule is, and you have to identify what is that. I'm not sure if I have, yeah. Now, this is a typical one. Now you have to tell which one. This is a typical question you would have. You can, this I've taken it from, I can't remember which year, one of the year this question was given. It said that compound A forms cis and trans isomers, but compound B and compound C does not. It is very obvious. In this, you see that there's a carbon-carbon, and this carbon has this one group attached to it, and on this carbon, it has this one attached. I will draw it here for you. I have to go back to the one. What is the compound? C double bond. One has CH2 and the other has CH3. And I have to go back to the molecule. So you will see that this, I can either, 1 minute, just a second. It doesn't matter how I draw it, but I can draw it. Now this is a typical cis. Now for a trans, the CH3 will go up and the H will come down, but the bond, double bond doesn't shift. And you can see it has two different groups on each one. Whereas when you look at this one, you see here, there is nothing attached. So hence compound B cannot have isomerism, a cis or trans, and definitely compound C is a straightforward. There is no double bond, and hence there is no it cannot form a isomer. So this is how you rational between it and give your explanation for what it is. Give your explanation that carbon-carbon bond, there are two different functional groups or two different groups attached to it, and that is what is a requirement for the cis and the trans one. And this, you need to specify it, you need to draw it, and the key thing, again and again I repeat, you need to mention that the cis and the trans isomerism can only happen if there is a carbon-carbon double bond. That's the first condition. Second condition, on that each carbon, there should be two different groups attached. If it is not attached, it cannot do an cis or trans isomerism. Students, this question normally never misses the question paper. It has been always there, and it normally is an excellence question.
Sujata, there's a question just popped up there. If you go back to the previous one, I was just wondering why there's a CH2 at the top there, and I think that's what the question is. Okay. Why does the left carbon have 5 bonds?
Which?
Yep. So just on the slide that you were just on.
Yeah.
The one with the drawing.
Yeah. Yeah, this one. Are you talking of?
Yep. And so just looking at that, the left-hand carbon is it going up to a CH2 at the top?
Yeah.
And it's got a double bond to the carbon on the right?
Yeah.
And it's got a bond to the CH3 on the left?
Yes.
And a bond to the hydrogen on the bottom?
Yep.
Is it meant to have that many bonds?
No, it is not. The CH2 can go off because there's a double bond. Normally, 4 bonds, the CH2 need not be there.
Got you. Awesome. Thank you. I think that probably cleared up the question from Rachel.
Yep.
Cheers.
That's okay. Thank you, Rachel, for clarifying. Okay. Now, this is what I was mentioning to you at the start. So this is now, once we have finished that, I'm going back to the reaction question. In the reaction questions, what you need to, that's why I said there is a lot of reactions for you to look at because you are new to this topic, and this topic has a lot of reaction which you need to remember. And the best one I would say is go to No Brain Too Small. You will find the summary chart already done. But just by looking at the summary chart, it is going to be confusing. So I would say keep that as in front of you and redraw it again in your own words so that you understand what each reaction is. Now, what you need to remember, another shortcut is you have a couple of the reactions, which is an addition reaction and which is an elimination reaction. Now, when in an addition reaction, what we follow the rule is rich gets richer, and in the elimination reaction, it is the poor gets poorer. Now, the basic thing is that when you are adding something to it, when you are adding additional allergen or you're adding amine group to it, remember those functional groups gets added to the carbon which has the maximum hydrogen. Similarly, in the elimination reaction, the hydrogen which is removed goes out from the carbon which still has the least number of hydrogen attached to it. That is the key things you have to remember in an addition. So with an addition, you are getting alkene might be changing into a halogen or alcohol, any of those. But when that functional group is added, it gets added to that particular carbon which has the maximum hydrogen attached to it. In the opposite way, in an elimination reaction, that particular carbon which has the least number of hydrogen, that is the one where the hydrogen is taken off by the reaction. I've put this here, this as a, and this I've taken courtesy of GED Science resources. You can see this here, elimination, alkane getting done to a haloalkane or an alcohol, and in an elimination, haloalkane or an alcohol is reduced to an alkene. So where the hydrogen gets removed from the one carbon, from the carbon which has the least. Now, alcohol in presence of KOH, which is aqueous, you will get a haloalkene. Haloalkene in presence of ammonia in warm conditions or a heat is provided will turn into an amine. Haloalkane in presence of SOCl2 will go. Now remember, it is not added. This is a catalyst, and in presence of that catalyst, it converts into an alcohol. So this is a summary of the addition, elimination, and substitution reaction. So these questions come to you and ask you for explanation. You still have to follow the protocol of how you write a reaction. That is, they don't expect you to write an equation. The equations are not, but you need to explain step by step what is a catalyst, how does it happen, what happens to it. Each of those steps needs to be provided. I have also provided a complete chart of all the reactions, but I would say this is becoming a bit confusing. So what I would suggest is please go back to the No Brain Too Small. It has broken down for you in simpler ways, and go through it, write it in your own words. When you redraw them in your own words, it becomes easier for you to understand. There is time. Your exams are only on the 3rd. You have time to revise them. Now, as I told you how to write the major and minor reaction questions. So this is the steps you follow. You are writing about the reaction, that is propanol to all forms propane. What is the conditions needed? What are the reagents? What is the reaction type? Writing the structural formula. Second part, you label them. What is a major? What is a minor? So these are the key things. And if you take your NCA questions, any of them, please follow the steps and you cannot go wrong. So once you practice it a couple of times, it becomes very, very clear for you how to go about answering this one. Polymers. Now, polymers again form up. Sometimes the polymers form identifying, first thing is a monomer, So remembering one thing, a monomer can be a double bond. And when you are adding the same molecule every time you're repeating the monomer, the double bond is not there. So you have to, how you identify, explain the definition of addition, and when the polymerization is happening, the double bond is gone. So what you look again is describe the two groups of each end of the double bond carbons. You describe what is being added, and you write the structural formula. Now here, this is 1,1-dichloroethene. And now when you're repeating it, so I have to repeat, I'll repeat, the double bond goes off, and you keep on adding the same thing again and again. So here, so this whole thing is your monomer, and when I'm writing it again, I'll write it for you. So it was C, double bond C, Cl, Cl, and H, and H. Now when I'm going to draw the polymer, what I will do is, this is my entire monomer. This has to get repeated again. So when I draw it, C double bond, sorry, C, single bond C, there is a Cn, there is a Cn, there is a H, there's an H. Again, the same thing repeats. Again, this becomes my first set, first unit, second unit, again the same. This is how and remembering while drawing the polymer, the double bond has to go off. This is called as a monomer. And the addition of this, the entire process, here the addition is called as polymerization. The whole process is called as polymerization. And each one is called a unit, which repeats. The monomer repeats 3 times. So you're writing it 3 units of repetition. And here, this is the one part which I was telling you about, writing about the unknowns. So you are given 4 separate colorless organic liquids: ethanol, ethanoic acid, hexene 2-ene, 1-aminohexene. So how do you write a procedure to identify each of these organic liquids using only the reagents listed below. So you have to now remember, this is a procedure. So this, you are writing a scientific method of how you can identify, how you will. So you have to identify what are the reagents used, what observation will you see with each one of them, and how you will eliminate each one and identify. And once that is gone, you will do with the rest. Now here, let's say the first time you're identifying ethanol, then what is left is that then you will say you will go to the other one. That particular ethanol bottle is kept aside. Then you will test the next reagents with each one, and what will you identify? So this question, you have to use your scientific method, your process of asking. These are the main things. It is a simple compared to your any other topic. This does not have surprises, but this only has that you have to repeatedly write the answers, So one main question you can look at was, because it's an organic one, you will have to name, or a structural formula will be given. You have to write its name, or a name is given and you have to write its structural formula. The other questions would be on anything of your reactions. including your CRIS and trans, which will be there. Most of the time we see is that when a question about writing the name or drawing the structural formula is given, it gets associated also with the CRIS and the trans question. The second questions could be anything about your reactions, writing the reactions on any one of them using your addition, elimination, substitution reactions. And the last one would be the identifying the unknown. These are the key questions that we have come across and which have repeatedly been asked. So any questions? That was the slides, and the slides I will share with you all. You can later on have a look at it. And please do go to No Brain Too Small, where there are collated answers, questions of the past and past years, and also answers are there. What I would give you the tip is, please do not copy the answers. Read it and try and write it in your own words. That was the end of this. Any questions?
Thank you, Sujata. There's no further questions at the moment, but probably just to reinforce one of the things you've already said. Working through the questions on your own first time is really powerful, and I'd almost even do it in one color of pen before I then use my notes, and then add anything that I've added in my notes in a different color before finally checking the schedule and seeing how what I've done matches with the schedule. And if you do that for a number of different years' past papers, then you'll certainly be very well prepared for your exam.
Yeah. And I will also add to that, if you have not gone through the GIZ science resource, it gives you how to prepare to write the excellent question. As when I come to the next one, when I'm talking about the after a break, when we come back on our reactivity, I have put in the link to the websites where you can have a look. But I would reiterate again the same thing. Organic chemistry is easy, but at the same time, it is easy to make mistakes because you cannot memorize them. You need to write and practice to get there. And I would just go by what Doug has said. Write your answers in one colored pen. And then once you look at the schedule, see what are the missing words you have missed to write in, add it with another colored pen so that every time you write it, you will become thorough in your reactions. The best way to go about learning all your reactions is look at the summary of the reaction chart, redraw it in your own way so that you remember the way, and when you write it, you know you have made a design or you have put a color code, and those colors remain in you for when you're writing, trying to remember in an exam condition.
Thank you, Sujata. We'll give it a moment just in case there are any last questions. Otherwise, we'll wrap up a little bit earlier than expected. Yeah. And then we'll be back on at 7:10, wasn't it, Sujata?
Yeah. Yep.
Okay. Doesn't seem to be any other questions through chat. I've put up Sujata's last presentation in the description for the video from last night. And I'll do the same, as Sujata said, with the presentation from this session as well. All right. Thank you very much, guys, for coming along. And thank you very much, Sujata, for presenting.
No worries. I'll see you at 7:10.
Thank you.
Yeah, thanks.
All right. I've just ended.